Friends, let's start the practice set. Okay?
Friends, we are going to start the practice set 2.5. In this practice set, the first sum is activity example. In this example, they're given to us one example, that is ax square plus bx plus c equal to 0. Okay, suppose in which if the value of b square minus 4ac is equal to 5, then what are the nature of roots? As we studied, b square minus 4ac, if this one is equal to 0, then roots are what? Yes, real and equal. Okay, that is very important one. Okay, now suppose b square minus 4ac, if this one is greater than 0, then roots are real and unequal. Okay, okay friends. Now one more condition is there, that is very important, that is nothing but b square minus 4ac is less than 0, means it is negative, then roots are not real. Understand? Now if you observe here in the given example, that is what b square minus 4ac is what? 5 here. Okay, because of this 5 which is positive, means this is greater than 0. Then what are the roots here? Real and unequal. We can write here roots are real and unequal. You can write here distinct also. Okay, now what about this minus 5? If b square minus 4 is minus 5, then this is negative. So what you can write? Roots are not real. Understand? This is the procedure. Try to follow and try to just observe here. Okay friends? Now see here, we'll think about the second sum. See here, sum of roots. Sum of roots means it is alpha plus beta, that is minus 7. Okay, and product of roots means what? Alpha into beta, that is 5. As we know, the standard form, which is x square minus in bracket alpha plus beta into x plus alpha into beta is equal to 0. Now in this particular standard form, we'll put the values of sum of roots and product of roots. See here, what will come here now? X square minus, here alpha plus beta is what? Minus 7. Okay, plus, what is alpha into beta? This is 5. Okay, equal to 0. So what will come here now? X square minus minus plus 7 x plus 5 is equal to 0. So here we can write the quadratic equation, which is what? Right here. Okay, we'll write here x square plus 7x plus 5 is equal to 0. Understand? Okay, we'll take now next one, third sum here. Okay, look here, what is the third sum? Here alpha and beta are the two roots of quadratic equation. Here the quadratic equation is given, that is 2x square minus 4x minus 3 equal to 0. So now we are going to find alpha plus beta and alpha into beta. As our previous discussion, what tells us? Look here, that is x square minus alpha plus beta x, okay, plus alpha into beta is equal to 0. Now the given equation I'll convert in that form. So that is 2x square minus 4x minus 3 is equal to 0. Okay, but we don't need here 2 because see here 1 is coefficient. So here also I'm going to make here 1 is coefficient, means divide to both sides by 2. What will come here now? That is x square minus 4 upon 2 is what? 2x minus 3 by 2 is equal to 0. Okay, now just compare here. What will get here? So alpha plus beta is equal to 2 here. So straight away we'll write here 2. Now what about alpha into beta? Here plus sign is there. So we can make like this one also. Look here. We'll write in that form. That means alpha into beta is what? Minus 3 by 2. Understand, friends? This is the procedure.
Friends, this is question number 2 of practice set. Find the value of discriminant. Discriminant means we have to find delta or b square minus 4ac. Okay, you can use delta or b square minus 4ac out of these two anyone. Okay, see here, they given to us some examples. These are the first results here. Look here, first one, x square plus 7x minus 1 equal to 0. From this information or from this quadratic equation, we have to find discriminant's value. First, tell me first whether this equation is in neat form or standard form or no. Yes, this is in standard form. So look here, the above equation is in the form of ax square plus bx plus c equal to 0. From this information, we can compare a for 1 here, b for 7, and what about c? Minus 1. And we are going to find value of b square minus 4ac, which is discriminant. We can write here delta also. Or you may write here delta means discriminant is equal to b square minus 4ac. Now I put the values here. B square means 7 square minus 4 into a for 1 and c for minus 1. 7 square 49 minus minus plus 4 ones are 4, 4 ones are 4 here. Yes, this is 53. This is what? You may write b square minus 4ac or deltas. Okay, from this only we can think what is the nature of the quadratic equation, nature of the root of the quadratic equation. Here it is positive, means this quadratic equation has real roots and distinct also because of delta is positive. Okay, that is not here. Only we have to find discriminant, but we can think for the next purpose only. Okay, now here also. The above equation is in the form of, first check whether it is neat form or no. Yes, that is what wrote here. It is in the form of ay square because variable is y plus c equal to 0. Therefore, by comparing a equal to 2, b equal to minus 5, and what about c? That is 10. Now we are going to find delta, means discriminant, that is b square minus 4ac. b square minus 5 square minus 4 into a for 2 and c for 10. Minus square is always positive. 5 square is 25, it is minus. 4 to the 8, 8 tens are 80. Now tell me what? 25 minus 80, it is what? Minus 55. This is delta, means discriminant. Think here, delta is negative. What are the nature of the root? Yes, what will the roots? Roots are not real. Why? Delta is negative. B square minus 4ac is negative. That is why here the roots will be compulsory. It is what? Not real. Okay? But that is not here. Only we have to find here B square minus 4ac, which is discriminant. What will be here? Again it is in net form. Very similar right here. Yes, what you can write here? The above equation is in the form of, in which form that one? That is ax square plus bx plus c equal to 0. So by comparing a equal to root 2, b equal to 4 and c equal to 2 root 2. Okay, now delta, we have to find b square minus 4ac. What about b square? Which is 4 square minus 4 into a for root 2. And what about c? 2 root 2. 4 square 16. Here it is minus. Okay. 4 2s are 8. Okay. Root 2 into root 2. It is just 2 only. Yes. Means what? 16 minus 16. This is 0. Look here. Discriminant will come here, not 0. Look here. Whenever the discriminant, that is delta, is 0, then again think about the nature of the roots. What will come here? Roots are real and equal also. Whenever delta is 0, then roots are always real and equal. But here we have to find only this much. Discriminant's value we have to find. Understand, friends? Friends, in this third question, we have to determine the nature of the roots of quadratic equation. So what will be the nature of the roots? Okay, nature of the roots means what? Either it is real or equal, real or distinct, or not real, like this. Okay, that is depend upon totally discriminant. That means we have to find first discriminant's value, and after getting the value of discriminant, then we'll discuss about the nature of the roots. Okay, see here. Again, very similar as like we solved in previous sum, here also we have to find very similar manner. The above equation is in the form of ax square plus bx plus c equal to 0. Just by comparing a equal to 1, b equal to minus 4 and c equal to plus 4. Just as usual, we have to find b square minus 4ac's value. See, b square, which is minus 4 bracket square, minus 4 into a for 1 and c for, again here also, 4. Look here. Minus square is plus 4 square, 16. Minus 4 ones are 4, 4 fours are 16. Here it is 0, which is delta. Look here. If delta equal to 0, then tell me what are the roots? Roots are equal. Yes, and real also. Like this. We can write here roots of quadratic equation. Roots of given quadratic equation are real and equal. Yes, this is very, very important. Here we can say real and unique solution also we can get. Unique, but only one root here. Because both the roots are same, we can just write once only. So you can say unique root also. Okay? Here, again very similar manner. The above equation is in the form of, very similar manner here as well, right? So it is, the variable is y. So a by square plus by plus c equal to 0. So a equal to 2, just compare. B equal to minus 7, c equal to 2. Again delta, b square minus 4ac, b square minus 7 square. Here minus 4, a for 2 and c for again 2 here. Minus square, it is plus 7 square, 49. Minus 4 to the 8, 8 to the 16. Okay, now just subtract. What will get here? 9 minus 6, 3. 4 minus 1, 3. Here, this is the delta, which is greater than 0, remember. It is positive, no? So greater than 0. Greater than 0 means, as we know, roots are real and distinct or unequal, also we can write. Okay, therefore, roots of given quadratic equation are real and unequal, or you may say distinct also. Okay, similarly this one also. Again we can write here, the above equation is in the form of, but variable is what? M. Remember that one. Here am square plus bm plus equal to 0. Okay, now a for 1, b for 2 and c for 9. Just compare here. So delta, which is b square minus 4ac, b square, that is 2 square minus 4 into a for 1 and c for 9. So 2 square means 4 minus 4 ones are 4, 4 nines are 36. Here it is minus 32. Look friends, this is negative will get here. So what will be the roots? Roots are not real. Okay, so we can write here, therefore roots of given quadratic equation are not real. Why? Because of delta is negative. Look here, less than 0. That is why roots are not real. Understand? This is the procedure. See friends, in the fourth sum, form the quadratic equation from the following roots here. There are 4 examples. Here these are the first 2 sums. Look here. By using these 2 roots, we are going to form the quadratic equation. See first, it is very important. Alpha is first root, means 0. And what about beta? That is second root, 4. Now we need alpha plus beta and alpha into beta to form quadratic equation. Okay, means what? Alpha plus beta, just by adding 0 plus 4. Yes, that is 4 only. And what about alpha into beta? This is 0 into 4. That is 0 only. We know, what we know, that standard form of that quadratic equation, which is nothing but x square minus sum of 2 roots. Yes, into x plus product of 2 roots. Yes, which is equal to 0. Like this. Or you may write here x square minus alpha plus beta x plus alpha into beta equal to 0. You can write this one only. Instead of writing this whole part, we can write like this also. Now just try to put the value only. See first. X square minus. What about this alpha plus beta? We just get that one is what? 4. There it is x. And what about alpha into beta? It is 0. So that one no need to write. So this is the required quadratic equation. You can write here. This is required quadratic equation. Yes, look how simple it is. Here also we can write. Again, alpha equal to 3, beta equal to minus 10. What we need? We need alpha plus beta. 3 plus, that is minus 10. So 3 minus 10, here it is minus 7. What about alpha into beta? 3 into minus 10. So minus 30. We know that. Yes. And what we know? X square minus alpha plus beta into x plus alpha beta equal to 0. They can ask, in the variable x they can ask, means this is the formula. If they can ask, like in the variable y, so you can write here y square minus alpha plus beta into y plus alpha into beta equal to 0. It is dependent upon. If they are not given to us anything, just write in the variable x here. Now I'll put the value. X square. What about alpha plus beta? That is minus, already is there. This is minus 7, which is x plus alpha into beta. This is again minus 30. Write that for in bracket. So x square minus minus plus 7x, here plus minus minus 30 equal to 0 is the required quadratic equation. Look how simple it is. Okay? Here, the remaining two examples. Here also we have to form the quadratic equation. They are given to us alpha and beta are the two roots. Okay? See here, the first one. That is third one. See here, alpha is equal to half and beta is equal to minus half. To form quadratic equation, we know alpha plus beta and alpha into beta, both we need here. So we'll find first. That is alpha plus beta, that is half plus minus half. Here it is half plus minus minus half. So here it is 0. This is alpha plus beta. Okay? And here we need alpha into beta as well. What is alpha? Half into beta minus half. So into is there. So straight away numerators multiply. 1 1s are 1, 2 2s are 4. Here plus minus minus. This is alpha into beta. Okay? Now we know that. What we know? Here it is x square minus alpha plus beta into x plus alpha into beta is equal to 0. Now in this standard form, we are going to put the values of alpha plus beta and alpha into beta to get quadratic equation. X square minus, what about this one? It is 0. X plus this one is what? Minus 1 by 4. That means because of it is 0, just remove that term here. X square plus minus minus 1 by 4 equal to 0 is the required quadratic equation. Understand? So simple all these are. Now the second one, that is fourth one. See here, alpha is equal to 2 minus root 5 and beta is equal to 2 plus root 5. Here these are the two roots. From these two, we are going to form quadratic equation. So again here also we need about alpha plus beta, that is 2 minus root 5 plus 2 plus root 5. Now these two getting cancelled, 2 to 4 here. This is alpha plus beta. Okay. Now very similarly we can find here now alpha into beta. Okay. What about this one? 2 minus root 5 into 2 plus root 5. Okay, here this is nothing but a plus b, a minus b. Means what? A square minus b square. So here it is 2 square minus root 5 square. So 4 minus here it is 5. That means minus 1, which is alpha into beta. So after getting these two, we know that. What we know? Very similar here also. Just have to write here also. That is x square minus alpha plus beta x plus alpha into beta is equal to 0. Now just try to put the values here. This is x square minus 4x plus, that is minus 1. So in the next step, we'll write x square minus 4x plus minus 1 equal to 0 is the required quadratic equation. Like this, we can solve. We can find or we can form the quadratic equation by using two roots. Yes, friends? And you can also take some roots yourself and try to form one quadratic equation. In the fifth sum. What is that fifth sum? See here, they're given to some information about that one. Okay, some of the roots of given quadratic equation is nothing but double the product of the roots. Okay, sum of the roots of given quadratic equation is equal to double the products of the same roots. And the given equation is that given to us, in that there is k, and we are going to find that k. What is that equation? X square minus 4kx plus k plus 3 equal to 0. Okay. Now, in that quadratic equation, there is the value, or there is the term k is there, and we have to find that value of k here. Okay, see first. This is the fifth one. X square minus 4kx plus k plus 3 equal to 0 is given quadratic equation. Okay, is given quadratic equation. Okay friends, now we need what? Alpha plus beta and alpha into beta. They are given to the relation between sum of the roots and product of the roots. So if you observe here, because of here the term x square has no coefficient, means 1 is there. So if like that only, then we can straightway compare with this one with that standard form. Then we can find alpha plus beta and alpha into beta very easily. Okay, see here, we know that, what is that? X square minus alpha plus beta into x plus alpha beta equal to 0, where alpha and beta are the two roots. Okay, now look here. If you observe here, this is nothing but 4k is equal to this alpha plus beta. Can you observe here? Yes. And here, what about this one? K plus 3. This is alpha into beta. Finish. From these two, we can straightway compare. We'll get here. This is 4k and alpha into beta is equal to k plus 3. Same example we can solve by using alpha plus beta is equal to minus b upon a and alpha into beta is equal to c upon a also. But this is very easy by this method. That is it. Okay. Now both we know here, but the given information is what? Okay, sum of two roots is equal to double the product of two roots. That is given to us. Means what? Alpha plus beta is equal to twice alpha into beta. Is it correct? The given example, the wording also very important. What is that? Sum of two roots is equal to twice or double the product of two roots. Okay, like this. Now both we know here. What is alpha plus beta? This is 4k. Here it is 2. What is alpha into beta? That is k plus 3. Only by simplification. This is 4k. Here it is 2k plus 2 3s are 6. Now straightway by simplification, what will you get here? 4k minus 2k, which is equal to 6. Therefore 2k equal to 6. Therefore k is equal to 6 by 2. Hence k is equal to 3 here. Okay? See, this is very simple example. We need only to find value of k. Understand friends? See, is there any doubt here? You can solve the same example with compare with that standard form ax square plus bx plus c equal to 0, and we can find a value, b and c. From that alpha plus beta and alpha into beta also we can find. Yes? But here in this one, straightway by comparing we can find the values of alpha plus beta and alpha into beta. Okay? Friends, before starting that sixth sum, see, okay, just try to observe here. This is alpha square plus beta square. Okay? This has no formula, but we are going to form this one in the form of alpha plus beta and alpha into beta. Just try to observe here. This is nothing but alpha plus beta bracket square. Is it equal? No. In this part, there is plus 2 alpha beta is there. That is the extra part, but that one we don't need to make equal. So that is why right here minus 2 alpha beta. Is it correct? Yes, it is very, very important one. Always, okay, sometimes in the further examples in that word problem something, here maybe it is alpha square plus beta square. But sometimes they are given to us like alpha minus beta also sometimes given. Okay, at that time you can write here plus 2 alpha beta also to make equal here. This is very important. Look here alpha square minus 2 alpha beta plus beta square. But that minus 2 alpha beta is extra. To make equal, we write plus 2 alpha beta. Okay, it's very similarly here. We can write here alpha plus beta, okay, bracket square. So here we can write alpha minus beta square. Is there both are equal? No, here plus 2 alpha beta is there and here minus 2 alpha beta. But we are going to make equal, so I will write here 4 alpha beta. See here minus 2 alpha beta. Minus 2 alpha beta plus 4 alpha beta. Again we get here plus 2 alpha beta, and now both these are equal. When we can use these all things? If they given to us the difference of two roots, okay, and sum of the two roots, here product of roots, like this in example will come, at that time we can use this one. Okay, very important part this one. Now here sometimes alpha cube plus beta cube, like this example also be there. So at that time, just try to observe here. Here I will write here alpha plus beta bracket cube. Is it correct? Here in that one, plus 3 alpha beta into alpha plus beta is extra. After expansion this one. Okay, plus is there, so we'll write here minus 3 alpha beta into bracket alpha plus beta. Just try to observe here. This is the formula of a plus b bracket cube. What is that? A cube plus 3ab into bracket a plus b plus b cube. That plus 3ab into bracket a plus b is extra term here. That one here, not here. That is why that one we are going to remove or make a balance. That is why we are going to write this one. You can use the formula of a plus b bracket cube. Okay, and try to simplify, verify whether it will come or not. Okay, similarly here alpha cube minus beta cube. Here also very similar. I'll write here alpha minus beta cube. Alpha minus beta cube. What will come here now? Here it is minus 3 alpha beta into alpha minus beta is extra term. So we will write here plus 3 alpha beta into alpha minus beta. Like this we can write. Okay, but mainly here the very important part is what? This one and this one are very important, because we know here alpha plus beta, alpha beta, alpha plus beta, alpha beta, and alpha plus beta, like this. But when difference of two roots will come now, at that time we can use these all things. Okay friends, make one screenshot, okay, and try to store in your memory. Okay, this is very important one. We are going to use all these in further examples. Okay friends? See friend, in the sixth sum, alpha and beta are the two roots of given quadratic equation, which is y square minus 2y minus 7 is equal to 0. That is given to us. From this information, we are going to find alpha square plus beta square and alpha cube plus beta cube we are going to find. Okay, see first here. Here we will write here y square. This is sixth sum. Y square minus 2y minus 7 equal to 0 is given quadratic equation, and alpha and beta are the two roots of given quadratic equation. Okay, now see here, we can compare this one with our standard form. Okay, we know that. What we know here? Here y is there, so we'll write in the form of y. Y square minus alpha plus beta into y plus alpha beta equal to 0. Look friends, straight away we can write here. What about alpha plus beta? Tell me. Yes, here it is only 2. Don't write minus, because here also minus. Okay, and what about alpha into beta? Here it is minus 7. That one is nothing but like this. Is it correct? Now look here, plus plus is there. So alpha into beta is nothing but minus 7. So these kinds of very silly mistakes, don't repeat this one. Don't make these kinds of mistakes here. Okay, now we get here alpha plus beta and alpha beta both we know. Now what we need? We need first alpha square plus beta square. Look here, alpha square plus beta square. That one we just discussed. Yes, what is that? Alpha plus beta bracket square. Here that term is extra. Which term is extra? Plus 2 alpha beta. That one we don't need here. So write minus 2 alpha beta. Finish. Now in that one, try to put the values here. What is this? 2 square minus 2 into what about alpha beta? That is minus 7. So here it is 4 minus minus plus 2 sevens are 14. This is 18. This is what? alpha square plus beta square. Very similarly, alpha cube plus beta cube also we can find. What is this? Just we discuss about that one. Alpha plus beta bracket cube. Here the term which is extra plus 3 alpha beta into alpha plus beta which is extra. So that one we don't need this one, this side, that is why write minus 3 alpha beta into alpha plus beta. Is it correct? So it's like these all expressions, try to remember and try to think what will come here. Okay, now we'll put here. What is alpha plus beta? Here it is 2. Just we'll find that one. That is 2 cube minus 3 into. What about alpha beta? That is minus 7. Okay, into again alpha plus beta, which is 2 here. Look here, 2 cube. Is it 6 or 8? 8. Don't write 6. If 2 into 3, then 6. It is power. 2 cube means 2 into 2 into 2. It is 8 here. Minus minus plus. 3 sevens are 21. 21 twos are 42. Therefore, how much will come here? This is alpha cube plus beta cube. This is 50. Understand? But it is very, very important. Just try to remember this one. Okay, friends? See, friends, in this last example, in these two quadratic equations, they are given to us, the roots are real and equal. So from that information, we are going to find the value of k in both examples. Okay? See first here. The first one, we'll write here 3y square plus ky plus 12 equal to 0 is given quadratic equation. So now we are going to compare this equation with our standard form. Okay, the above equation is in the form of, yes, it is very, very easiest one. Ay square plus by plus c equal to 0. Therefore, a for 3, b for k, and what about c? That is 12. Okay, real and equal means what? B square minus 4ac equal to 0. So we will find first value of b square minus 4ac. See here, which is discriminant. We will find that one. What about this one? This is k square minus 4 into a for 3 and c for 12. So this is k square. 4 3s are 12, 12 12s are 144. But the given quadratic equation has real and equal roots. Real and equal roots. It is given. Therefore, what we can think here? B square minus 4 is equal to 0. Therefore, k square minus 144 equal to 0. Take that 144 to that side. Therefore, by taking square root, what will get? K is equal to plus or minus 12. Okay? See, this one is very important. And k has two values. One is plus 12 and minus 12. Just try to think here. If we put here plus 12 here, then also okay. If we put minus 12, then also it is possible. Yes? Therefore, we can write here k is equal to plus 12 or k is equal to minus 12. Understand? Very simple it is. Very similar example here also. But first of all, it is not in the standard form. We'll write in that standard form. Look here. That we can write here kx square minus 2kx plus 6 equal to 0. Now it is the given equation. It is a quadratic equation. Okay. Now the above equation, just very similar. The above equation is in the form of, that is nothing but ax square plus bx plus c equal to 0. So just compare. A is equal to k, b is equal to minus 2k. Is it correct? And c is equal to 6. We'll find here also b square minus 4ac value. You can find here. This is minus 2k square minus 4 into a for k here. And what about c? That is 6 here. So minus square, that is plus. 2 square 4, k square is k square. Minus, here 6 4s are 24k. This is b square minus 4ac. But given quadratic equation has okay, right here, real and equal roots. Okay. Therefore, what you can write here? B square minus 4ac equal to 0. So by comparing these two, 4k square minus 24k equal to 0. See here? Look here. We can solve this one by two ways. We can take 4k common also, or we can take this 24k to that side also. I'll take 4k common. Okay, what will remain here? One more k remains here, only 6, 4, 6 are. Already the k is there. So, whenever the product of two terms is 0, either first one may be 0 or second one may be 0. Okay, see here. Therefore, we can write here 4k equal to 0 or k minus 6 equal to 0. This is k equal to 0 upon 4 and here k equal to 6. So, here k equal to 0, k equal to 6. But look friends, whenever the value of k comes 2 times or 2 terms you can get here, try to check whether which is possible or not. See, if we take 0 itself, if we put here 0, then this is not a quadratic equation. Yes. Or if we put here k equal to 0, here also k equal to 0, then both these terms getting cancelled. Now we will get only 6. But the 6 and 0 both are equal? No. That is why k is equal to 0 is not possible. Right here, k equal to 0 is not considerable. Okay, therefore k equal to 6. Like this we can write. You can write reason also, because k equal to 0, then this is the equation is not satisfied. That is why we can write k equal to 6. Understand friends? Like this we can solve all the examples of this practice set using the relation between sum of two roots and product of two roots, or some coefficients, that is a, b, c, like this one. Understand?